Imagine a world where the sky was not just a limit, but the ultimate battlefield. A world where two superpowers clashed in a relentless arms race, each yearning to claim dominance. That was the 1960s, the peak era of the Cold War, as the US and the Soviet Union engaged in a fierce competition to assert who was truly in charge. The United States, in pursuit of absolute advantage, harbored a bold dream: to build the fastest strategic bomber in the world, a machine capable of flying at more than 3 times the speed of sound. Would this dream become a reality, or just an expensive illusion? With a singular purpose: to rule the skies, with a colossal investment reportedly equivalent to the cost of building an aircraft carrier at the time, they named this masterpiece the XB-70 Valkyrie. The name Valkyrie, recalling the powerful warrior goddesses of Norse mythology, clearly expressed America's ambition and faith in this machine. They believed this would be the future symbol of power, an untouchable, high-speed ghost capable of penetrating any enemy defense. But why, after only a few years of operation and billions of dollars spent, did the US military ruthlessly retire this advanced supersonic bomber? The Soviet Union's military potential in the 1960s to 1970s developed rapidly and dramatically, prompting the Americans to consider creating weapons capable of delivering atomic bombs deep into enemy territory. Furthermore, these weapons also had to be durable enough to travel the enormous geographical distance between the two nations. That was why the XB-70 Valkyrie was born. It wasn't just an airplane, it was a statement of will, a testament to America's superior technological capability in a volatile era. But could a flying machine overcome both distance and time? The XB-70 Valkyrie was a supersonic strategic bomber developed by North American Aviation. It was hoped to replace legends like the B-52 Stratofortress and the B-58 Hustler. This aircraft was designed to penetrate deep into Soviet airspace at high altitudes at supersonic speeds. The US Air Force hoped this would be the future symbol of its air power. The design project for this aircraft began development in the late 1950s, and the first aircraft took flight in 1964. It carried a heavy mission, immense expectations, but could it bear that responsibility? Despite its high speed, the XB-70 was not recognized as an interceptor. Its core mission was simply to be the fastest strategic bomber on the planet, with a flight speed reaching Mach 3+, more than 3 times the speed of sound. America's masterpiece could carry a maximum fuel load of 177,000 liters. According to military intelligence, when the XB-70 became operational, it was considered the most excellent bomber on the planet. With a length of 57.6 meters, a wingspan of 32 meters, and controlled by a 2-person crew, with a maximum wing loading of 246 tons, it was truly a giant of the sky. With supersonic cruising speed in combat, its operational range could reach 6,900 kilometers. Could any enemy escape its reach? To achieve such terrifying speeds, this super bomber was equipped with 6 General Electric J93-GE-3A jet engines. Each engine had a raw thrust of approximately 84 kilonewtons and an afterburner thrust of up to 128 kilonewtons. With a maximum ceiling of 23,600 meters in the late 1950s, this was an altitude that almost no surface-to-air missiles could reach. It was not just an aircraft, it was an extraordinary engineering achievement, a symbol of pioneering spirit. Could this technology forever maintain its position? Along with its high speed, the XB-70 was an unparalleled solution for a strategic bomber to counter air defenses and even jet interceptors within enemy territory. Additionally, it featured a canard design, flat tail, and large delta wings, giving it a somewhat futuristic look. The styling of this 1960s masterpiece seemed more like a spaceship than a bomber. Military experts even nicknamed this weapon the Mafia bomber. But would its futuristic appearance and advanced technology be enough to ensure its survival? When the XB-70 flew at high speeds, temperatures generated could reach 400 degrees Celsius. If aluminum alloys were used, like in conventional aircraft, they would not be able to withstand the heat. To solve this high-temperature problem, difficult-to-process titanium metal was chosen at the time. Titanium alloy was a very expensive material, and titanium processing technology was not yet mature. Therefore, it can be said that engineers found many new ways to incorporate this material into the body of the XB-70, and it's understandable why it was so expensive. Is any technology too costly to achieve dominance? It can be said that with the cutting-edge technologies of its time and a maximum flight speed that could be 3 times the speed of sound, when it was introduced, this supersonic strategic bomber almost met all the requirements of the US Air Force, including intercontinental operational range and a large payload like the B-52 strategic bombers, or a speed of Mach 3, faster than the Mach 2 capability of the B-58 Hustler supersonic medium-range strategic bomber. The XB-70 was capable of dropping conventional bombs or strategic and tactical nuclear weapons. Fairly speaking, almost no Soviet aircraft of the same type at that time could compare with this king of the skies. But can a king reign forever when the world is changing so fast? US experts endeavored to achieve a series of breakthroughs in the technology used to build this bomber. In addition to its unique shape and special structural materials, its engines were also reinforced to withstand high temperatures and varying air intake velocities, optimizing engine operating time and lifespan. Indeed, it is hard to believe such a powerful aircraft was designed just a decade after World War II. It was a marvel, a testament to the explosion of innovation. But can technological marvels resist the tide of history? Despite possessing state-of-the-art technology and impressive wide-area operational capabilities, the XB-70 had weaknesses that led to its gradual retirement only 5 years after its research and development began. One of the first weaknesses was its confrontation with its biggest enemy, missiles. While the US developed the XB-70, the Soviet Union was also secretly pouring immense effort into increasing the range and speed of its surface-to-air missiles. This was a relentless race, a competition where each side had to constantly outdo itself. But can defensive technology keep pace with offensive technology? Not long after the US masterpiece was completed, the Soviet Union's surface-to-air missiles also gained the capability to reach higher altitudes, including the XB-70's ceiling. A prime example was the S-75 Divina SA-2 guideline missile, which could reach a range of 23,000 meters to 24,000 meters. This meant that the Valkyrie's altitude advantage, one of its core strengths, was severely threatened. The enemy did not stand still, and the aerial battlefield was changing rapidly. Could the XB-70 adapt to a new, unforeseen threat? To avoid missiles, the US Air Force shifted to a doctrine of performing low-altitude airstrikes, where missile radar line of sight was limited by terrain. In this low-altitude penetration role, the XB-70 proved ineffective compared to the B-52. The B-52, with its large payload capacity and lower cost, became the more advantageous choice for the new tactic. This marked a significant turning point, an admission that a machine designed for the high skies could not adapt to the challenges at lower altitudes. Could a revolution in tactics render a superweapon obsolete? In terms of cost, this super aircraft was indeed very expensive, dozens of times higher than the B-52, while its range was shorter and it carried less weaponry. Due to the aircraft's exorbitant cost exceeding budget capabilities and technical maintenance difficulties, US military officials gradually became wary of this new aircraft. Although a technical marvel, the price paid for this superiority was too high, pushing the project into a difficult situation. Can technological value overcome financial burdens? Furthermore, at that time, the Soviet Union also had a similar program, the Sukhoi T-4 aircraft, also known as the Sotka, a bomber that could also reach Mach 3 speeds, or the MiG-25 Foxbat interceptor, with its high altitude and high speed capabilities, capable of shooting down the XB-70. Both superpowers were developing machines of comparable or even superior capability, creating a constant race. This raised questions about the exclusivity and advantage the XB-70 once held. Could a worthy adversary overshadow the glory of a masterpiece? In addition to surface-to-air missiles and the development of similar aircraft, the successful development of intercontinental ballistic missiles, ICBMs equipped with nuclear warheads, especially the emergence and formation of the Minuteman nuclear defense system, created a dead hand that military officials referred to in the previous dossier, which was the decisive factor rendering the XB-70 unsuitable. An ICBM could perfectly replace the role of bombers, making it unsuitable for the US Air Force. Although this project consumed $1.5 billion of taxpayers' money, concurrently, the US began developing intercontinental ballistic missiles at the same time. Washington was striving to reduce its reliance on bombers. Could a new technology completely replace an old one, no matter how advanced it was? As a result, the 35th President of the United States, John F. Kennedy, decided to eliminate the XB-70 Valkyrie's frontline bomber role on March 28, 1961. This was perhaps the final shot, killing the dream of this super aircraft. This decision was not just a change in policy, but an admission that the world had changed. The death of a project is not always a failure. Sometimes it is a sign of evolution. Can the end of one era usher in another? Nevertheless, the XB-70 Valkyrie development program continued for research purposes, and the XB-70A prototype made its first flight on September 21, 1964, landing at Edwards Air Force Base in California. This was one of the most strictly guarded bases of the US Air Force, but unfortunately the test did not yield as many positive results as expected. It only achieved Mach 2.5 compared to the Mach 3 speed mentioned in the designs. This small difference, though not significant, said a lot about the technical challenges the project faced. Can a scaled-down dream still retain its initial appeal? According to sources that military knowledge researched, a typical test flight proceeded as follows. After takeoff and landing, the pilots began to ascend at speeds from 740 to 1,100 kilometers per hour. The wingtips were deflected 25 degrees to increase stability in the transonic region. When a certain acceleration was reached, the external windshields of the cockpit were raised, after which visibility was almost zero, and the aircraft was controlled solely by instruments. Then the landing gear was stowed at an altitude of 9,753 meters, with the wingtips deflected to 60 degrees. The XB-70 continued to climb to 15,240 meters, after which the aircraft would gradually reach its stable altitude of approximately 21,000 meters. This complex procedure not only demonstrated the aircraft's sophistication, but also the bravery and skill of the crew. Can humans fully trust a machine that pushes their own limits? The not-so-successful experimental method of the first prototype led the US National Aeronautics and Space Administration, NASA, to agree to cooperate with the US Air Force to build the second XB-70 Valkyrie, the XB-70B. This collaboration breathed new life into the project, opening up new research possibilities beyond its original bombing role. It showed that even if a project fails in its initial objective, it can still find another purpose, another value. Can collaboration between organizations save a project on the verge of failure? However, on June 8, 1966, an unforgettable day in the history of US military aviation in general and North American aviation in particular, a terrible mid-air collision occurred between two peak achievements in military aircraft: the superbomber XB-70B and the F-104 Starfighter. The irony was that this happened while the aircraft were participating in a photo shoot for promotional purposes. That moment, an event that was supposed to be a demonstration of power and beauty, turned into a horrifying tragedy etched into the memories of those who witnessed it. Can moments of glory be erased by a single tragic moment? After the photo shoot, the F-104, piloted by Joe Walker, unexpectedly collided with the left vertical stabilizer of the XB-70B and then exploded, bursting into intense flames right in the sky before the camera lenses. That moment shocked the public then, and even later. An accident no one ever wanted to see, a symbol of power destroyed before the public's eyes. It was a painful reminder of the fragility of technology, no matter how advanced it may be. Can an unforeseen incident bring an end to a major program? As for the bomber, it continued to fly but gradually lost control and altitude. In that moment, the two pilots of the XB-70B, including Chief Pilot Al White and co-pilot Carl Cross, were making every effort to regain control, but they failed. Only one of the two pilots on the bomber survived, albeit with hand injuries due to the ejection seat design itself. This incident can be considered a serious loss because the cost of building an XB-70 at that time was up to $700 million US. Can a single incident cause irreversible consequences? Perhaps you didn't know that the cost of building a Kitty Hawk-class aircraft carrier at that time was only about $260 million. Thus, the cost of this super aircraft was nearly 3 times the price of an aircraft carrier. It was also a tragic event and a blow to the pride and honor of the US Air Force, not to mention the loss of life of the pilots. A price too high for a photo shoot, a price too high for a shattered dream. Can this loss be quantified in money or only in pain? Some critics argued that the US spent a huge sum of money just for this aircraft to break world aviation records. But given the technological advancements of the era, the obsolescence of the XB-70 was inevitable. It's just that the plane crash accelerated this obsolescence. It was like an expedited destiny, an end coming sooner than expected. But is an end always a complete failure? Due to testing incidents and immense manufacturing costs, although it was commissioned into the US Air Force, the XB-70 Valkyrie was never recorded participating in any battle throughout its operational life. It was a magnificent warrior that never fought, a powerful weapon that was never used for its intended purpose. Is there any meaning in possessing unparalleled power but never having the opportunity to demonstrate it on the battlefield? It can be seen that the design of this super aircraft was geared towards a high-end strategic bomber. If circumstances had been favorable, this aircraft would have become a national treasure and a bomber that instilled terror in adversaries. However, due to incidents with test aircraft and the emergence of numerous supersonic fighters and missiles from opponents, the XB-70 project was rapidly brought to an end. This clearly exemplifies the saying, "Pride goes before a fall." Yet based on the technical specifications that military knowledge mentioned earlier, it is likely that no strategic bomber to date can truly compare with America's supersonic bomber in terms of materials and speed. So was the XB-70 Valkyrie truly a failure? Or was it simply a vision too far ahead of its time? Due to too many persistent flaws, poor operational capability, high operating costs, and the US Air Force's lack of need for such a high-speed supersonic aircraft, in early 1969 the XB-70 Valkyrie bomber was entirely transferred to NASA for the agency to use it for the purpose of launching space shuttles into space. A change of purpose, a demotion from its original role. But was this a sad ending or a new opportunity for an extraordinary machine? The US National Aeronautics and Space Administration took excellent advantage of the XB-70 Valkyrie's speed potential and high-altitude flight capability. The mechanism for launching space shuttles from this aircraft was quite simple. The aircraft would fly at its maximum altitude and maximum speed with the space shuttle on its back. Then, the space shuttle would separate and utilize its existing Mach 3 speed, 3 times the speed of sound, to easily glide out of Earth's atmosphere. This was an incredibly innovative application, demonstrating that the value of technology can be found in unexpected places. Can a failure turn into a stepping stone for other successes? During its use, NASA found that maintaining and sustaining the support crew for the XB-70 was too expensive. Therefore, they reached an agreement with the US Air Force to conduct research on other aircraft, the AS-12A and AS-12C. The XB-70 Valkyrie project thus had to close. It made its last test flight on February 4, 1969. A quiet end for a loud machine, a silent farewell for a grand dream. Can advanced technologies be defeated by maintenance costs? After the XB-70 related design projects were suspended in 1969, the remaining XB-70 Valkyrie bomber, AV-1, made its final flight to Wright-Patterson Air Force Base to be displayed in the National Museum of the United States Air Force near Dayton, Ohio. Its mission now is simply to serve the public, as one of the products considered a symbol of the American aerospace industry. It is no longer a war machine, but a legacy, a reminder of an ambitious era. Can a past icon continue to inspire the future? Perhaps you didn't know, even though the XB-70 Valkyrie super aircraft was decommissioned and remains only symbolic, 15 years later, its technical and technological advantages were successfully applied by the United States to aircraft like the B-1B Lancer. From this, the superior scientific and technical prowess and military strength of the Americans can be seen, and personally, for military knowledge, this can be considered an aircraft that inspired the future, not only with its excellent designs and technology, but also as one of the greatest aircraft the US Air Force has ever produced. So, can the failure of a project still leave a lasting legacy? Looking back at the story of the XB-70 Valkyrie, we cannot help but feel a mixture of admiration and a touch of regret. It is a powerful testament to humanity's aspiration to conquer the skies and its technological superiority in a volatile era. The cost of up to $700 million for an aircraft in the 1960s was an astronomical figure, an investment that many considered wasteful. But can we truly quantify the scientific breakthroughs, the technical knowledge gained from such an ambitious project? Were the lessons learned about heat-resistant materials, supersonic aerodynamics, or automated control systems worth the price paid? The Valkyrie was not just an aircraft, it was a flying laboratory, a tool to push the boundaries of what humans could create. Although it never fulfilled its original mission, it paved the way for many subsequent aviation technologies, like a silent pioneer exploring new lands. The XB-70's story reminds us that innovation does not always lead to immediate success, and sometimes the biggest failures contain the seeds of even greater achievements. It is a lesson in adaptation, in accepting the changes in technology and military strategy. Today, as we admire the remaining XB-70 in the museum, it is not just a giant hunk of metal, but a story. The story of a nation's will to soar, the ingenuity of engineers and pilots, and the cruelty of fate. It stands there, a monument to a supersonic dream, a reminder of what can be achieved when we dare to dream big, but also a warning about the limits of ambition and the ever-changing nature of the world. So, what do you think of this super bomber? Was it worth the $700 million the US spent? Or is it a symbol of waste, a testament to the fleeting nature of technology?